All right, here we go. 22-1. Raise your hand if you've heard of the Richter scale before. Sweet. That's what we're going to be talking about today. The Richter scale kind of it deals with earthquakes. It kind of goes into tomorrow's lesson too. So on page 343, if you want to follow along, I'm going to read about the Richter scale. This is all true information. In 1935, Charles F. Richter developed the Richter magnitude test scale to compare the size of earthquakes. The Richter scale is based on the amplitude of the seismic waves. You guys know what amplitude of a wave means? The height. Yes. So it's based off the amplitude of the seismic waves recorded on a seismograph at various locations after being adjusted for the distance from the epicenter of the earthquake. Richter assigned a magnitude of 0 to an earthquake whose amplitude on a seismograph is 1 micron, or 10 to the negative 4th centimeters. According to the Richter scale, a magnitude 1 earthquake causes 10 times the ground motion of a magnitude 0. A magnitude 2 earthquake causes 10 times the ground motion of a magnitude 1 earthquake. This pattern continues as the magnitude of the earthquakes increase. So is a 2 magnitude double a 1 magnitude? No, it's 10 times more. This pattern continues. Number 1, write down your answer to part A. James, how does a 5 earthquake compare to a 4? You got a 5 is 10 times more than a 4. So see what you can do with B and C. All right, so a 4 compared to a 1. I know from a 1 to a 2, that's 10 times greater. And the 3 is 10 times greater than that. The 4 is 10 times greater than that. The 10 times 10 times 10 can be written as 10 to the third. Or it's kind of nice to write out that number so we can actually see it. 1,000. The 4 earthquake magnitude is 1,000 times more ground motion than the 1. That makes C pretty easy. We've already got it set up. How does a magnitude 4 compare to a 0? Well, that's 1 more times 10. So 10 to the 4th. So 4 zeros. The 4 is 10,000 times greater than the 0. I found this table interesting at the bottom. The table below describes the effects of earthquakes of different magnitudes. So just read that to yourself. Have any of you, whether in Illinois or elsewhere, ever felt an earthquake of any kind? Like you were miles and miles away, but you still felt something. Nobody? Nobody laughs. I think this is so interesting that the 8 is serious damage across hundreds of miles. Just try to think of like hundreds of miles. Serious. You guys have seen serious damage from tornadoes, right? And that's usually just like a single like path. This is like circular. It's just going out in all directions. I'm assuming, for hundreds of miles. And then I can't imagine 10 times that. And then I just couldn't imagine anything like that. All right, flip the page. Number 2, complete the table to show how many times as great the ground motion is when caused by an earthquake as compared to a magnitude 0. They give you magnitude. That's the Richter scale. A1 is 10 times. A 2 is 10 times 10. 3 is 10 times 10 times 10. You can see all you're doing is multiplying by 10, which in turn adds a 0. Don't forget your commas. It's much easier to read a number with commas in it. Yeah. Yes, but I'm okay with that. I like to write it with 0 so I can really see how big that number is. What is that big number? A million? No, a million is way up at 6. What is this large number here?
A trillion.
Let's see. So that's a million. That's
10 billion.
this is a million. This is a billion. So 10 billion. Yeah, we haven't hit a trillion. So 10 billion. 10 billion. Holy cow. Number 3. In parts A through C below, you will graph the data from item 2. This is item 2, the table we just made. Let the horizontal axis represent the magnitude of the earthquake. So in your graph, go to the x-axis and write magnitude, parentheses Richter. That's where it's coming from. The number, the magnitude from the Richter scale. That says let the horizontal axis represent the magnitude of the earthquake, and the vertical axis represent the amount of ground motion caused by the earthquake compared to magnitude 0. I'm going to write ground motion. Just know it's the ground motion compared to 0. Go ahead and plot those points that we just did in the table in that graph. Terrible graph, right? That's why there's another graph below. Terrible graph because it only hits 1 point. It might say to use a graphing calculator or not. B, plot the data, so same table, using the other grid. So they have now expanded it. Now plot your points in the next grid. We still have the same X and Y. Magnitude, Richter scale, ground motion. This graph didn't get much better. Sure, there's 2 points, but that's still a terrible graph, which is why there's a third and final graph. C, on page 345, scales may be easier to choose if only a subset of the data is graphed and different scales are used for horizontal and vertical axes. So for both of these, they counted by ones and counted by ones. Here they counted by tens and counted by tens. It's not always the best thing to do because our Richter's going to 10, our other one's going to 10 billion. So I'm going to give you time to think about what you would like to count by. Now you're only graphing a subset of the data. You do not have to put the entire set of data, just a subset. Don't forget to label your axes. Are you guys counting by ones in the magnitude direction? That would probably be best because if we count by twos, we're going to get to 10. Then we'd have to get to like 10 billion in the y. So let's just count by ones. Knowing I'm going to get to 5 for magnitude Richter scale reading, I need to get to 100,000. Should I count by thousands? No, I'd have to get to 100,000. What do you guys think we should count by? 10,000 is a good idea. You don't have to label every one. Label the first one, and then a few more as you go up so it's easy to find. You can save yourself some zeros and write 10K instead of 10,000. Once you're done, connect your points. Raise your hand if you've got your points connected. Okay. Now here's what I really want to know. How many of you guys did this? See my problem with that? What's the problem?
It doesn't go to the negative.
This doesn't work for this word problem. There's no negative numbers on the Richter scale. There's 0 is the lowest. So let's make sure we stop at 0. Every time we've been doing homework, our domain has been negative infinity to infinity. That will always happen if it's not a word problem. This word problem, you're going to 0. I would say we could include 0. And we're going to 10. It's never been recorded, so maybe you don't want to include 10, but I think with the Richter scale you could. That's your domain for this problem. Number 6, skipping down to 6. In item 3, which is all these graphs, the data were plotted so that the ground motion caused by the earthquake was a function of the magnitude. 6a, is the ground motion a result of the magnitude of the earthquake, or is the magnitude of the earthquake a result of the ground motion? You understand the question? Is the ground motion a result of the magnitude? So is the magnitude, which is the Richter scale, is the ground motion a result of that? So the magnitude results in ground motion, or is the magnitude of the earthquake a result stemming from the ground motion? Now do we understand the question? Saying what happening from what? Yeah, in real life, this is happening. The ground is shaking, and then some smart guy with some cool tools says that's a 6. It'd be very weird for some guy to say a number and the ground starts moving. So the ground motion happens first. We would say the Richter magnitude is a result of ground motion. So that means our graphs aren't great. They're actually opposite of what they should be because we didn't do it wrong. They told us what to do. This usually implies that this comes first and this is the output, which is kind of backwards. The ground's going to shake and then we're going to assign a Richter magnitude to it. So turn the page, let's fix it. There's a new graph there for you. We need to flip the axes to what actually happens in real life. The X is the ground shakes first. And the output is the magnitude Richter scale reading. Go ahead and fill in your labels and your points. You'll notice there's not the same number of lines. Like magnitude, if I count by ones, I'm getting to 10. That's going to be huge on the other end. So I'm going to mark every other one as 1 so that I get to 5. This one only has about 5 dashes. The other one had about 10 dashes. So I'm going to have to cover twice the distance. We counted by 10,000s. This has half as many dashes. So we're going to have to count by 20,000s. I know at 10,000, the Richter was magnitude 5. At 10, at 1, was it? No, that was 100,000. At 10,000, it was. What other one did we know? Look at the table. 5 was 100,000. 4 was 10,000. So 10,000 was a 4. And then we had like barely a little bit different to graph these. So I can connect the dots. Let me show you what somebody suggested a different hour to count by. They're still doing ground motion. They were kind of looking at this table and looking at this ground motion here. So 10, 100, 1,000. So they counted by 10, 100, 1,000, 10,000, 100,000. You see a problem with that? That's not the same distance. From 10 to 100 is a distance of 90, and 100 to 1,000 is 900 apart. You have to count by the same increment along one axis. You can pick a different number along this axis, but you must remain the same. There are times when breaks are allowed in the graph, but not in this problem. Do you have a question, Jonathan? Oh. All right, so we're going to finish up here with 7. They want you to do the domain and range. I forgot to have you guys label these. The one you just did, please call that M of X. I skipped one as we were going. Go back to your best graph on 345. This is where your axes were flipped, but you still had a lot of points. Label that G of X. Now stay here, so I want you to write an equation if you can. Try to write an equation that would result in this graph, remember, which came from this table. So I need a function, so if I plug in 3, I get 1,000. A function, so if I plug in 4, I get 10,000. Jordan, you got a function there? What? 10x,
Or no.
10 to the x. There you go. Yep, because this would be linear. 10 to the x power. If I plug in 2, 10 to the second 100, plug in 3, 10 times 10 times 10, 1,000. Yes. Exponential. Now, question 7 is going to ask us to compare this graph with m of x. Let me see if I can copy this nicely. Oh, new page. Okay. Did I erase some of this? Right. Wait. Let's compare the domain and ranges for these functions. Your book has it laid out, domain and range to compare in item 7. You can kind of do it wherever you want. Domain. For this first one, g of x, the domain in words is the magnitude. The lowest magnitude is what number? 0. I would say we could include 0 because you can actually have a. Does the Richter scale have a 0 on it, or was 1 the first one?
It has a 0.
It does. I don't see a 0. I would be a little iffy. I would go with it. I would think 0 would be okay. So 0. What's the highest number we can go in the x magnitude direction? I would say 10. Again, I would be a little lenient if you said infinity because there could be something bigger than a 10 at some point. I think we would all die, but I don't know.
At that point, the Earth would just
Like if it's hundreds of miles, we wouldn't all die. Like if it happened in Australia, we'd be okay.
Well, it depends on.
No,
If it's like a-
tsunamis.
But does the earthquake cause a tsunami?
Oh, yeah.
Yeah.
Aren't those two different things? Is a tsunami just an earthquake in water?
If it happens on like a shift and an earthquake and then they open a hole in the water sweeps in and then it goes back up.
That's what a tsunami
But
is.
it-
When the
it
plates
has-
move, water goes down and has to come back up
Back
somewhere.
Yeah, like you know, like when you like go, that's when it goes. the water
We
goes
should
up.
watch videos on tsunamis. It seems very interesting.
It's
really
And freaky.
Tsunamis sound way worse than Earth.
What if like there's an earthquake and somebody like falls in? Wouldn't that just be terrifying?
Yeah.
Somebody
Sinkholes
like-
scare the crap out of me.
That'd be kind of cool to see what it looks like. Did you know there were
Yeah,
sinkholes
right.
here at HHS?
There is.
I like to think so.
I'm convinced there's a sinkhole in Miss Lalonde's room. She told me it's a drain to the like sewer, but I think it's a sinkhole.
Like over by where you park to get into the track, there was some pretty big holes over there. You wouldn't die, but they fixed them. All right, back to this.
They would die.
Let's do domain for this function. In words, I already erased it, but this was ground motion. It's technically ground motion compared to a 0, but you don't have to be that specific for right now. The lowest ground motion I would say is 0. Yes, it could go up higher than the scale, but let's stop at what the scale says, which I think was 10 billion.
How did they do that?
Go ahead and fill in the range for both functions. Do you notice something about your answers? Yeah. Not only do the words switch, but the numbers go along with it. The domain of one becomes the range of the other, and vice versa.
Doesn't that mean we can do that thing where you put them together, composition?
Very good. We actually are going to kind of do something with that tomorrow.
Actually?
Actually, you deserve a sticker.
Oh.
Let's go to 8. Not 8.
It's a sticker.
C.
Yeah.
A portion of the graphs of m of x and g of x are shown on the same set of axes. Describe any patterns you observe. I don't know if I would necessarily call it a pattern. There is a pattern, but
The reflected over
yes.
y equals 2 or what? X?
X. There you go.
I was
They
gonna say one of X,
reflect-
but it's-
Over the line y equals x. Let's draw in the line. That's a linear equation with a y-intercept of 0, slope of 1.
I can't do a straight line.
Jonathan, did you have something different? Okay. Every x and every y flips. So if this is the point over 1 of 0, then on this graph there exists a point over 0 of 1. Every single point flipped will be on the other graph. These are inverse functions, which is why, as Julian was saying, if we do composition, one into the other, it will sort of cancel out and we get x. Part of tomorrow's lesson. There was homework listed, but it's mostly just Richter scale questions, which wasn't really math related too much. So I'm just going to go with no homework for today.
It's a great day.
Favorite teacher.
Your teacher's favorite should not be based on